Well, hi, good morning. Thank you so much for keeping me company here in my shop while I look at another clock radio. I don't know anything about this other than what you know already. It's pretty cool looking. I haven't tried anything with it, so let's find out if this thing works. And so where are the radio knobs? Oh, they're missing. So we're missing the two knobs that go here. Let's look it over. See what we can figure out. So this has got to be the second counter, I would imagine. So this is probably just rotating by all the time. Clock dial face has gone dark yellow, or is it the plastic, or is it just the background? I like the numbering, the style of the numbering. Very nice. Okay, let's go around the back. Well, let's see. So let's start with the cord. Is the cord dangerous? This is not a polarized cord. It's pretty dirty. But I don't see any breaks on it. It's probably fine to use. You can see a bit of the radio antenna protruding through here. It's loose. Well, that's not a particularly good sign. This knob will not fit through this hole. The back is held on with various screws. All four of these screws are different. There's more. They're all different. So this guy has been through something. He has been through something. So we will not plug it in until we've had a look inside to see that the plastic here is shattered right where it meets the that centerpiece. Can you see there's just a little bit of a crack spidering out from the center? Probably from the radio being put face down, maybe even having stuff piled on it for a period of time. Let's get the back off and we'll see what's happening here. Okay, I need a plethora of screwdrivers. Let's start with the flat ones. How many can I get out with a flat screwdriver? That's 2. 3. Don't think that's going to work. Oh, maybe. All but 1. Now, I think the antenna was probably attached to the back of this, but maybe not. Last one, Green Roberts. So there's a sticker on the back here. You can certainly see the warning. This radio clock to be used only 105 to 225 volts AC, 60 cycles. Jewel Radio Corporation, something or other Avenue of the Americas, New York. Well, it's an American-built radio. It's got a thing here so you could actually hang this on the wall if you wanted to. Here it comes. Okay, the antenna's coming with it. Okay, right away you can see that some work has been done in here. Like this capacitor. I see a diode here sitting. Probably this is out of the circuit now. This is the other rectifier. Somebody's written the tube types here. 12BE6, 12BA6. Ooh, that doesn't look right. Does it? Yeah, that looks right. Very dirty in here. Wow. Looks like the bulk of the original parts are still in it. Like these antenna connection wires have been redone. Looks like the antenna's been just taped back on here by somebody. Barely so. This may not be the original antenna, even. Antenna connections, pretty simple. One one side of this antenna coil going to the capacitor frame, and the other side going to the tuning capacitor here to tune against this coil. Let's see if this moves very, very freely. It's rubbing on a wire down there. The wire not quite in the right spot. Not that it's harmful, but it's just... a lot of dirt in the capacitor. So it looks like this radio, how is it held in there? Oh, whoa! I hadn't really looked under here. Oh my gosh, all kinds of beat up old parts. But somebody did this. Somebody replaced the the power supply capacitor. Well, do we dare turn this guy on just as it is? Do we dare do that? Looks like all the tubes are in. 1, 2, 3, 4 tubes. And a diode rectifier. What's this thing back here? Looks like a big capacitor sitting back there. Why would there be a big capacitor back there when he's got these in here? Could be he left the original capacitor. Actually, here it is, here. Oh, it's completely loose in the radio. It's just hanging in here. Oh, that's not very good. Why is it even there? Looks like it's still connected. Ooh, well, I'm gonna go drink some coffee and think. Should we turn this guy on or not? All those in favor? Okay, after some coffee cup consultation, yeah, let's turn this thing on and see what happens. What's the worst that can happen? Nothing. Nothing really bad. Now the reason for that is I have ways to supply power that will prevent bad things from happening. So I'm going to restrict the amount of power that can come over to the radio by feeding the power through these light bulbs. In fact, just this one. So it's not going to be at full voltage, it's going to be somewhat reduced. If there's a short circuit in here, then what's going to happen is the light's going to come on over here really bright. That's all. The lights in my house will stay on. I won't pop the circuit breaker, and I won't rely on my house circuit breaker to interrupt what could be a small fault current in here, which would not be interrupted. And you just have a smoke and flames. So I don't want to have smoke and flames. Smoke, okay. Flames, no, we don't want flames. Okay, so no knobs. I'm not going to get too far without some knobs. I need some knobs. Okay, I have to fetch a couple knobs here. Okay, found a couple of knobs for now. In fact, they're not bad. They're just very dirty, but the red color's not bad. It goes with this. Excellent. What luck. Okay, now I'm going to turn them on. We'll be looking at this side. By the way, I think I mentioned this was probably the second counter. This is actually the tuning dial, of course. So we're going to leave it tuned around 590. Okay. So parts that we're concerned about, pretty much right in here. These guys here all have some potential to be in trouble if there's something terribly wrong here. So now I'm going to throw the power on. Be able to read the power, that's the voltage level that's coming to the radio right on this screen here. And you can see the light in the background right here. Here we go. So the radio's not switched on. You certainly hear the motor going on the clock. The clock has no second hand, so we can't see easily, but if the motor's chugging, I will bet the clock is operating. And through this motor opening, there's an opening right here, you can actually see the motor spinning in there. I don't know if you can see this on the camera or not. Let's see if I can get it a little closer. Very hard to see on camera, but that through the hole there's a piece there that's spinning. And that's probably where the noise is coming from, although see it's getting quieter. Okay, ready to turn on the radio. So I'm going to cut the power. Now we know what the clock motor sounds like, so I won't be fooled by that. I'm going to turn this on. This time we should see these lights flash on, and then it should go down. How come no clock? No clock. What happened to the clock? Just because the supply voltage is pulled low by the draw from the radio, and the light bulb is dropping too much voltage, so the supply to the motor is only 56. Hey, listen to that. I heard sound, and then I didn't. Okay, so I can hear a little buzz coming out of the speaker. Turn up the volume. Okay, I don't think I hear a thing. No crackling, no nothing. Here, tune it. A little fat chance on this doing anything. Volume's up full. You know what? We're still running this radio with 56 volts. That's just not enough. 56 volts. Let's give it the works. What I'll do is I'll put in another light bulb here. This should raise the voltage right up to regular operating level. Around 100. It's just a wee bit low. Some interesting sounds there. You can see this tube glowing. One tube glowing, they're all probably glowing because they're in series. You can hear something now. Tune this radio. Oh, it's working. Now I've got the volume up full. That's not too good a showing. Something is interfering with something. You can hear a little click and a ding. I can't see what it is. I think it has something to do with this band. I don't think we're going to pick anything up. Okay, that's the demonstration. Now we need a plan of action to go forward with this radio. That was that's a very good starting point. Got sound coming out of the speaker. I mean, a lot of things are okay in this radio for it to do what it did. But not everything's okay, that's for sure. So now someone has worked on it. They've replaced the filter capacitor here. I didn't quite turn this right off. I'm going to turn it right off. So you could assume that the power supply filter is good. I didn't hear any hum. So problems lie elsewhere in this radio. Probably really the next thing to do is to test the vacuum tubes in it. I think that's got to be the next step. But I'm going to go have some coffee and think more about it. Okay, so I've acquired the schematic for that radio so I can check to make sure these are the correct tubes. This is a 50B5 output tube. It's correct. I'm sure the tubes are correct. I'd be surprised if the tubes aren't correct. So I already have this set for 50B5. Let's just go through it. 50 volts on the heater. JR 3562 38620 23 91. He's ready to go. The radio did have low volume, a chance for low, one possibility is a weak output tube, but there's many possibilities in a radio that has not been restored. Just a moment. I don't see that it's heating. tube sockets. Okay, it's heating up now. So first check is for shorts. Watching this light. No shorts appearing. Ready for the test. So 4700 is the throw it away point. We're on the second scale here. 4700. It's got to get above my finger here. And see, it came up and see it dropping. The pointer's dropping down. So this tube is definitely bad. Let's pop this on English. What does it say in English? Replace. Again, see it dropping down. Not a good sign. So, could this be weak enough that we get no output? I'm not sure about that. But we did get an output. The output was weak. The tube is weak. Hey, there you are. Put in a new 50B5 and I'll bet you the volume will come up. But that's only the first tube. The next tube we've got to do here, get it out of the radio. It's going to be, yeah, that's the tube being shook out of the radio. 12AT6. Now let me just take a peek at the schematic here myself and make sure that's really the right tube. Yep, 12AT6. Okay, we'll set this up and we'll do a test on that. Okay, there's 3 tests for this tube. Just clean it up a bit, but not where the words are. Okay. Let's double check. So first of all, 12 volts on the filament, and the numbers are 12AT6 37020 37020 18 and 57. Okay, good to go. First test, 3 tests on this. Just the 3000. A good test. Oh, it's not here. Yeah, couldn't find it on my roll chart. I have to look at a chart on my computer here. 755 is the reject point. So 755, way down here. I just got to get above my finger. Okay, short test. Okay. Flashing light is okay. Will you make it? Oh my gosh, look at this one. Let's just check my line voltage here, although it can't be that far out. Slightly. Yeah, but that's not going to mean anything. She's dead. She's really dead. Let's just double check my settings here. AT6, 18, and 57. So we have 18 and 57. Put it on English. What do you say in English? This is the same thing. Get rid of it. So this is definitely bad enough. Well, let's do the diodes. Let's do the diode, at least one of them, just for fun. Can you have a strong diode in a tube that's in this kind of condition? So 3602, so change the 7 to a 6. And that's all we're changing? Oh, we're changing the 6 to a 0. Wait a minute, that doesn't make sense. The numbers are, oh, looking at the wrong tube, 3702, 3602, and 3502. Yeah, we're just changing one number. Okay, so now we're going to test the diode. Oh, it's supposed to come all the way up to here. Just barely out. So this tube is just completely... You know, people must have been, like in the last days of this radio, must have had the volume up full or something to even play it. So this guy's a dud. Okay, so that's 1 week, one really bad, 2 more to go. Let's pull out the 12 BA6 here. Come on. 12 BA6. Is it really a 12 BA6? Yep. Yep. Good. This is a very, very common tube. Where's the words? Where'd the words go? They are right here. Is there really any advantage to a clean tube? Well, I guess it runs a slight bit cooler, but I don't think it has any electrical effect. Okay, we'll set this up for 12 BA6. Okay, let's double check the settings here. 12 BA6, 12.6 here, JR 3567 with a 2. 3567 with a 2 on the end. 983. We're good. P4 for a test. Make sure it's heating up. Let's see it heating up again. Oh, my poor tube tester, so worn out. Okay, watching the pilot light here. This isn't flickering at all. Maybe it's... Can't imagine the tube being... like the filament can't be open. Because it's a series of radio. Well, maybe I just can't see it. Oh, yep, I can see it. I can see it. What I'm doing is I'm getting down and looking across at the heater here. Okay, any shorts in here? No shorts being reported. On the 3000 scale, a bad tube just above the 2000 mark. So you gotta get all the way up here to qualify as a good tube, according to this tube tester. Okay, there we go. Oh, right where my finger is. So, just holding it for a bit. So this tube is also weak, but it would not stop the radio from working. So it's going to go back in the radio for now, because I don't think it needs to be changed. Again, it can't stop the radio from working, not like that other one. That one last tube there, just popping it out. Okay, this is should be a 12 BE6, I would guess. 12 BE6. Okay, words are there. Beautiful. I'll set it up. You know what? I'm going to let the video keep running here. 12 BE6 as it's right here. 12.6 JR 5762 with a 3. 5762 with a 3. 11. 63. Okay, and double check. 12 BE6 7562 3. Oh, I got this wrong. 12 7562 7562. Oh, I had that backwards. 3 11. Okay, that's why I like to double check these things, because I know myself. I've been hanging around with me for a long time. Okay, here we go. Check for the filament. think it's lighting again. Okay, we'll try the wiggle thing and watch the pilot light. Boy, hard to tell. I don't think the tube draws very much current, so. Okay, another way to tell is to run the short test and watch for the short light to flash. If it flashes, the tube is operating. Oh, there's a weak flash there. Nah, that was nothing. Okay, I don't think we got this going yet. Huh. I don't know. Yeah, I've got to fix my tube tester here. I can see this pilot light shaking up and down. You might get a weak connection on the heater and then get a low heater voltage, and then the test's going to suggest the tube is bad when it's really the tube tester. Come on, man. You can do it. I don't think I'm going to get a reliable test here. This is a bad tube. I have to switch tube testers. Get some certainty going here. There's nothing happening on here. Like the heater cannot be open on this tube. Oh, there it goes. Okay, the tube's half out of the socket though. Well, let's carry on. If the tube test says it's good, I'm sure it's good. If it says it's bad, I won't be sure. Okay, this is, oh. That's not good. Is that because I'm between things? No. I have a short on number 3. Now, I could look this up in the manual if I cared to, and I could find out what's shorted. Oh, I think I just disconnected it. Now, is it short showing up because I've got it half out of the thing? Can that cause a short? I think this is getting stronger as the tube warms up. I cannot test this tube in this tester with a short in it. Let's try it on another tube tester. Okay, bad tube. So bad tubes, I bend one pin inward, so I cannot mistake it down the road because guess what? I tend to not throw those out right away. Yeah, I'll get another tube tester in here and we'll check it out and see what happens. So the last tester I was using is a Stark 966, a very, very common tube tester. Yeah, this one's a Weston 981 Type 3. Another fairly common tube tester. Both of them are, let's double check here before I do that. Both of them are dynamic tube testers. 12BE6, so 13 is the number on the heater setting, 4 on the signal, 8L on the bias, 51763, 51763, and 3000, very good, 41, C. This is the plate setting here. Don't want to get that wrong. Okay, tube in. Now this guy also has worn out tube problems, which I guess is typical of any tube tester that's done a lot of work. And mine have done a lot of work for me. So maybe I'm the guy who's worn them out. Or so here we go. Okay, this also has a leak test. But this one's different. There's no neon bulb. Instead, the meter will go upscale if there's a leak. Here we go. Well, now, if some tubes, in fact, have shorts in them on purpose, and the tube tester tells you that by putting a code in here, which would be the letter F. But in the 12BE6, there is no such code. So this tube has got a short in it. That's a bad act. That's two very bad tubes. It's going right in the garbage can anyway. It's a danger. So I have to get out a 12AT6 out of my tubes here. Okay, I'm going to find a 12AT6. Okay, here's a 12AT6 we can try. Okay, 12AT6. It's sitting right on the short test. Here. Now, once again, is it warming up? Yeah, the pilot light located right near here. I wouldn't be surprised if that's so you can keep an eye on it while you're doing this. This is not I'm not showing anything here. You know why? Because we're testing a 12BE6. Oh my gosh, I got myself totally thrown off track here. Total. Yeah, coffee. I need coffee. Okay, so I've reattached to my head, and I think it's going to work now. 12BE6, and I saw the pilot light flash. Oh man, it doesn't take much to throw me off. I can't even blame it on my cats. Okay, anything funny about this tube? Watching the pointer now. No, perfectly normal. It's definitely lit up. So 12BE6. Doing the whole tube here at one time. 1570. So it should come up better than 1570, better than halfway. GM test. Oh yeah, she's a goodie. Okay, so this tube can't cause silence in the radio. So that's now every tube tested. I have to get a replacement for the 12AT6. Let me figure out how to put this one back in. Go in. There we go. Okay, that guy's in. The 50B5, let's just keep using that one for now. And a 12AT6. So I just had them in my hand. Oh, dummy. Well, I'm left with the impression I may have screwed up the tube test here. Oh, you know what? It was in the other tube tester, maybe. Because I don't remember setting this for 12AT6. That's probably because it was the other tube tester. Right, and I put this in here and got a short. Isn't that what happened? So this is the original again. 12AT. This is set for 12AT, but let's just double check. Signal level 1. 28L, you know, I don't remember setting this. 51760. 51760. 0300. I don't remember what I did. How did I get here? What's happening in the world? Here we go. No shorts. And then the test. Oh yeah, super weak because it's supposed to come up to 780, which would be up in this area here. Just barely. Yeah. Bend the pin again. I straightened the pin out on it. Bend it again. Throw it away. Throw it away again. Okay, so here's an alternative of my collection. Okay, it's warming up. No shorts indicated. Once again, 1286 first test, 780. 780 is about here. Oh, that's not very good. So it's under 780. Trust this? Yeah, the highest that ever comes is right there. So 780, that's 600, so probably not a good replacement. Shoot. Okay, so in here are more. That doesn't look like it. This looks like one. Okay, it's going to take me a minute to identify one for sure, so I'm going to stop the video here. Okay, here's one. I don't have many of these tubes. Okay, I'm not showing you short. There we go. So top of, that's well above. Well above. Now there's also a diode test. Hardly worth doing. This tube tester, I like to pull the tubes out. 01763. 01763. P000. P000. 45. 4 to 80. P1 and P2. Plate 1 and plate 2. There's two tests for this. Put the tube back in. Generally, I think if the triode tests good, the two diodes will also test good. We'll see what happens. Just for fun, we'll do the short thing. Oh, so much fun. Okay. I want to do diodes. So diodes okay, just have to come above my finger here. So it's in the okay range. Plate number 2, also the same. Good. This is a good tube. This is going to do the trick in the radio. The 50B5, that may continue to sort of depress the volume in the radio. Oh, this is tricky to get in. Well, okay, so I'm going to get the two tubes in there, and then we're going to play the radio. Okay, ready for another try here. Okay, we're going to go through the dim bulbs again. Guess maybe it's not turned on. Quite a strong hum just came out of the speaker when I turned it on. I saw a light flash, so there's a light in here too. Was that a light flashing or a tube? I think there's a light in there. Okay, we got a buzz. We're operating with 100 volts on the radio. Should be enough. You have to turn it up full to get volume, so gain output tube probably is responsible for that. Very weak. Got the antenna laying down here. What if I stood it up? I don't think that's going to make any. What are the chances of picking up a station? Full volume. Oh, not full voltage though. Yeah, there we go. full voltage. Extra 10 volts. Doesn't make really much difference. Back of the clock says Hayden Manufacturing Incorporated, Forestville, Connecticut. So the kind of hum that's in here is a little bit suspicious. Well, no, it's not going to pick anything up. Okay, next step will be tomorrow. I'm done for today. Tomorrow, pull this out, pull everything out, start working on it, change a few capacitors, poke around with it, see if we can get it working, figure out what they've done, why they've got these extra capacitors here with the big old guy still hanging in the background there. And as for the clock keeping time and that, it's not really a concern for me. I don't think there's anything I could do about it anyway if it doesn't keep time. But it probably does. It's a synchronous motor, and if it's operating, it'll probably have synced up with the 60 cycles. It's probably spinning at the right rate, and the clock is probably accurate. Okay, we'll leave it at that. So thanks a lot for watching today, and we'll get this guy all finished up tomorrow. Anybody smell smoke? No, I just smell the smell of a warm radio. Okay, see ya.